GCSE Physics boosters, pressure in a gas. In the particle model topic, this video is about pressure, what causes pressure in a gas. Now imagine you throw a ball against a wall. Now when the ball collides with the wall, it will exert a force on the wall. It'll be probably quite a small force for a very short time. So a graph of force against time would just be this little blip, okay, while the ball is actually in contact with the wall. Now, what would the graph look like if there were lots and lots of balls coming in different directions, traveling at different speeds, colliding with the wall? And the graph would look something like this. Lots and lots of balls, different speeds, different directions, banging up against the wall, lots of little blips, different sizes. Yeah. What we could say is that there is an average force acting on the wall. So a graph of force against time would look very random, but then the average force against time is shown by this red line here. So that's lots and lots of balls banging into the wall. Now, this balloon contains a gas. There is a huge number of particles, like in a balloon like that, 10 to the 24. So 1 and 24 zeros, that's a crazy big number of gas particles, all moving randomly in terms of their directions and in terms of how much kinetic energy they've got very, very quickly. You know, the average speed here is about 500 meters per second, and they are banging with the walls of the balloon, the internal walls of the balloon. And this is what produces the pressure which acts inside the balloon on the walls of the container. It's a huge number, massive number of air molecules banging against the walls of the container. And because they're moving so randomly in all directions, the pressure acts equally in all directions. One thing to appreciate is that you've also got the pressure of the air outside the balloon. Lots of air molecules banging into the external wall of the balloon. And that pressure will actually just be a little bit less than the pressure inside the balloon. The pressure outside, we call it atmospheric pressure. Now, imagine we have a container like a metal box, and it contains some gas and its volume can't change. In this experiment, the volume of the gas can't change. The volume is fixed. And what we're going to do is increase the internal energy of the gas by giving it some heat energy. So I've set up a Bunsen burner underneath it. We're giving it heat energy, and its internal energy will increase. So what difference will that make to, well, the temperature and the pressure of the gas? Well, obviously, if we're giving it internal energy, then the temperature is going to get bigger because the particles will have more kinetic energy. The gas particles have more kinetic energy, and there's a relationship between the kinetic energy and the temperature. Now, basically, the temperature is what we call the Kelvin temperature, is proportional to the average kinetic energy. If you go on and do A-level physics or A-level chemistry, you'll learn a lot more about this. But there's a strong relationship between the kinetic energy, the average kinetic energy, and the temperature of the gas. Now, the pressure will get bigger. Why? Because if the particles are moving faster, now there's two things. They're going to exert a bigger force on the walls. If it bashes into the wall faster, then the force will be bigger. Secondly, they will collide with the walls more often. Like a particle, if I get a pen going here, a particle is going to go something like bang, bang, bang. That's assuming it's going in this direction, bang. Now, if the particle's traveling faster, then it's going bang, 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 bang. Hopefully you get the idea. It will collide with the wall more often, and if there's more collision, then the average force will be bigger, so the pressure will be bigger. What is the relationship between pressure and temperature? You can do an experiment using this device here. You've got a fixed volume in this metal bulb. It's called a Jolly bulb, named after somebody called Jolly, probably. If you put that in a water bath and change the temperature, and then you measure the pressure, you plot a graph of pressure against temperature, and you get a straight line. As the temperature increases, the pressure increases. An interesting question is, if the temperature got less, then the pressure would get less. Is there a temperature where the pressure would be zero? Not on our syllabus, but it's an interesting point to make, and I'm sure some of you have heard of absolute zero. So these are the questions that you should be able to answer now. If we give heat energy to a gas, what happens to its internal energy? What happens to the average kinetic energy of its particles? What causes pressure in a gas? And why does the pressure increase with temperature? There are two reasons. Make sure you can answer these questions. If you can't, look at the video again.